Okay, question 19, the final question, but it is quite a big one. So, Ellie, a statistics student, of course, read a newspaper article which stated that 20% of students eat 5 portions of fruit or vegetables each day. Ellie suggests that the number of people who eat 5 portions of fruit or vegetables each day from a sample of size n can be modelled by the binomial distribution b n 0.20. So n is our number of people in the sample and 0.2 is our probability. Okay, for part A, there are 10 students in Ellie's statistics class. Using the distribution model suggested by Ellie, find the probability that of the students in her class, first of all, 2 or fewer eat at least 5 portions of fruit and veg each day. So, our distribution here is x binomially distributed, n is 10, p is 0.2. Now you can do this using your calculators. What we want is the probability that x is less than or equal to 2. So, doing it manually, for those that like to, we would get 10 to 0 times 0.2 to the power 0 times 0.8 to the power of 10, add 10, choose 1 out of 0.2 times 0.8 to the power of 9, add 10 choose 2 times 0.2 squared times 0.8 to the power of 8. So, whichever way you do it, to 3 decimal places, we should get 0.678. Cool. Okay, then for part 2, we want the probability that at least 1, but fewer than 4, eat at least 5 portions of fruit and veg each day. So, this is the probability that x is greater than or equal to 1, but less than 4. Now, if you like using your calculators to do this, you would need to do the probability that x is less than or equal to 3 minus the probability that x is equal to 0, which I suppose on your calculator would be less than or equal to 0. Without your calculator, and this is how I'm going to think of it, we want probability x is equal to 1 and probability x is equal to 2 and probability x is equal to 3. So, this is 10 choose 1 times 0.2 times 0.8 to the power of 9, add 10 choose 2 times 0.2 squared times 0.8 to the power of 8, add 10 choose 3 times 0.2 to the power of 3 times 0.8 to the power of 7. So whichever way you swing it, we should get to 3 decimal places 0.772. Cool. Okay, then for part B. Ellie's teacher, Declan, believes that more than 20% of students eat at least 5 portions each day. He asks the 25 students in his other classes, and 8 of them say they eat at least 5 portions each day. Part 1 asks us to name the sampling method used by Declan. So, this whole thing is about students. Declan had access to more students, so they fit the criteria of what this whole thing is about. This type of sampling is called opportunity. Opportunity sampling. Cool. Okay, then for part 2, we want to describe one weakness of this method. So, if we think about this, everyone that Declan and Ellie have asked are from the same college. It might be that students at this college are particularly healthy or unhealthy, so it's not a good representation of all students, country or worldwide. Okay, now finally, and we all knew it was coming, we have a hypothesis test to carry out for 6 marks. So, assuming that these 25 students may be considered as a random sample, we want to carry out a hypothesis test at the 5% level of significance to investigate whether Declan's belief is supported by his evidence. Okay, so with a hypothesis test, we first of all need to define our null hypothesis H0 and our alternative hypothesis H1. So, the null hypothesis always has the probability set to a value, so set equal to a value. So here, H0 is going to be such that the probability is equal to 0.2, and our alternative hypothesis is Declan's belief. So the probability is greater than 0.2. So remember, we are dealing with a binomial distribution. So under H0, x is binomially distributed and our n is 25 and our probability is 0.2. Now we could say where x is a student or is the number of students who eat at least 5 portions each day. Okay, so we know from Declan's sample of 25 students, 8 of them said yes. So what we want to do, using our binomial distribution, we want to work out the probability that x is greater than or equal to 8. Now this is 1 minus the probability x was less than or equal to 7. So, definitely use your calculators to work out the probability x is less than or equal to 7. So what we should get there then is the probability that x is greater than or equal to 8 is 0.109. Now, if you like, we could say that is 10.9%. Now remember that we are testing this at the 5% level. So 10.9% is greater than 5%. So what this is saying is under our null hypothesis, where our probability was 0.2, there is a 10.9% chance that out of 25 students, 8 of them or more, so at least 8, there is a 10.9% chance that 8 or more students would eat at least 5 portions each day. So, if it's 10.9% likely, with probability being 0.2, then H0 still stands true. So we accept H0 and reject H1. And then we would need to finish with a statement, something along the lines of, there's no significant evidence to support Declan's belief. Cool. Okay guys, that's paper 2 done. So, if you're watching this in 2018 and you're waiting for the in 2019 and you're waiting for the 2018 papers, they are coming. Bear with, get subscribed, and you'll know when they're here. Really hope you found this useful, guys. Good luck with your exams. Take it easy. Take care.